So today I am going to discuss the sixth problem of AtCoder beginner contest 244, which is shortest good path. So we are given a simple connected unrelated graph with n vertices and m edges. Now we have to find a sequence, and for every subset, you can read the problem statement here. It is written that this age denotes the parity of every node in the path. If si equals to 0, that means that in a I ith node appears even number of times. If it is 1, that means that in a the ith node appears one number of times, the odd number of times. So for every s, like for every mask case, bit mask case, we have to find the minimum length path, and we have to find the sum of this minimum length paths for all the bit masks. Okay, I hope you have understood the problem. So let us jump into the observation. So let us take the first example, which is 3 2 1 2 1 2 3. So let us take this example. So this is the graph. So 1 is connected to 2 and 2 is connected to 3. Now for every s, we are building the minimum sequence, subsequence, like sequence a. So for 0 0 0, like for every vertex appears even number of times, our sequence will be empty, and the length of the longest sequence, the shortest sequence will be 0. For 0 0 1, our sequence will contain only 1. For 0 1 0, our sequence will contain only node 2. For 0 1 1, our sequence will contain 1 comma 2, because both will appear odd number of times. For 1 0 0, our sequence will contain only one node, which is 3. For 1 0 1, 1 and 3 does not have any direct edge, so we have to connect it with 3. With 2. So 1 2 3, 1 2 3 has parity of 2 as 1, so we are adding 2 again. So now the parity of the 2 is 0, parity of 1 is 1, and parity of 3 is 1. For 1 1 0, 2 and 3 are directly connected, so length is 2. For 1 1 1, now both have parity 1, so both appears odd number of times, so we will connect 1 to 2 and 2 to 3. So if we add these values, our answer will become 14. Okay, so here is the answer 14. I hope you have understood this example also. Now the first approach which comes to our mind is doing bitmask dp, because the value of n is like 17. So we can do like n into 2 to the power n approach here. Order of n into 2 to the power n approach will be like right. It will pass. So the first thing which comes to my mind is bitmask dp. But if we do general bitmask plus dp with dfs, it will fail. Why it will fail? Because our graph could have cycles in it, and while we have cycles in it, it could be like the state of dp will be interconnected, and we can't depend on another state to like get the result of the current state. So that's why we can do like normal like dp dfs with recursion. Like let's say we are going from 1 to 2, the first state to second state, and now we go to second state to third state. Now when we come to state to first state, our answer of the first state will depend on the third state, so there would be a loop, and our solution will fail. So we have to think about something different. So the different thing is that we can do like bitmask plus dp with bfs. That is our desired solution. So our desired solution is bit plus dp plus dfs, bfs. So what we will do, we will push like in a queue, we will push like what will we push? We will push the current mask, and the current last node and distance, like what is not distance exactly, it is like number of nodes. So count, I can say count of nodes. Okay, so at the first, what are the base cases? The base cases are if the mask is like something the mask is something like 2 to the power I, then our node will definitely be I, and our count will be 1. This is the base case. For 2 to the power I, our node will be I and count will be 1. This is obviously the base case of our like okay, I think you have understood that. So at first I will push all 2 to the power I comma 1 for all I from 0 to n minus 1. Okay, so for all 0 to n minus 1, we will push 2 to the power I comma 1. So now what will be the transition? So for every node I, we can go to any of these child nodes, any of these nodes which are adjacent to it. So we will go to the adjacency matrix of AI. So our adjacency matrix will be AI. for every node j in this adjacency matrix, we'll go to it, and we'll do this. Our new mask will be 2 to the power I XOR 2 to the power j. Now our new mask will be 2 to the power I XOR 2 to the power j. Our current last node will be j, and our distance will be current distance, or count will be current count plus 1. So we will go to 2 to the power I XOR 2 to the power j, comma count plus 1. So I think you have understood the transitions also and the DP states also. So let's see my solution. Now here I am using zero based indexing, so I am decrementing the value of both x and y. So here I have taken a queue of length 3, array of length 3, and this is the distance array in which I will maintain the minimum distance for every mask, minimum count of nodes. Here I am calling it distance. The distance is the count of nodes in every path. So so for every mask I am counting the value of di. So firstly I'll be pushing one to the power I comma 1 in the queue, and I am making dp's are like kind of a visited array. I am making it 1 if the current node with the last node as I is already visited. And here the distance of mask, I have already told that the distance of any 2 to the power I will be always be 1. The distance or count of node in 2 to the power I mask will always be 1. Okay. So now while queue is not empty, we will pop the, I think you have understood this thing. We are popping from the queue, and like our distance or count will be the last value u2, and our current node will be 1, and our mask will be u0. So if mask equals to 0, we have reached for mask equal to 0, answer will be always be 0. So we are continuing from this state. Now our d mask, which is the minimum nodes in the path with mask, will be d mask comma distance. So now for every node j, I am doing new mask equals to mask or 2 to the power j. I have already explained why I am doing that. Now if the current mask with the last node as j is not visited, or the value of dp new mask comma j is 0, we are pushing new mask j and distance plus 1. Now we are also setting the value of new mask comma j is equals to 1. Now for every mask value from 0 to 2 to the power n minus 1, we are adding it with our answer, and at the last we are printing the answer. I hope you have understood my solution and the explanation also. If you have any doubt, you can ask in the comment section. Thank you. Please subscribe to my channel.